Okay, Assalamualaikum and a very good day. So this video is we will talk about we will discuss about one example that I can consider as CNN tutorial, okay, for this for a tutorial for CNN. So okay, as you can see here, this is the problems that I show in the slides there. Your employer has built a CNN model called AMENET, which is used to classify between cat and dog given an image of dog or cat. So this is the AMENET architectures. Okay, of course I just put it my names there. Of course this is not, if you google, you will not find this net in online. This is just a simple example so that you know actually how actually we can, given the architecture, and then how to design the code, and how to understand the problems there. So again, as you can see in this architectures there, like I said before, this format is only for this class or this course. So again, like I said, there's no standard representation. There's no standard architectures format. I means that you can do it in form of a drawing. You can also do it in text, but in this class we use the standard format like this, where actually this is only for these courses, because we don't have recently we don't have any standard to represent the architecture. So as you can see, we have 1 up until 8, so that is represent the layers. So we have input image there with the size 5 times 5 times 1. Of course, if 5 times 5 times 1, that means is what type of image is this one? Is it a color image? Of course no, because the depth size is equal to 1. If there's the color image, the depth size is equal to 3. So when you multiply with 1, it can be binary or it can be grayscale image. And then okay, that is a kind of question that we can, you need to familiar with it, because you must understand the architecture, and then that kind of question that can be asked. Okay, for examples, this kind of CNN can be considered as a binary classifier. Can you justify why? That is why that is because of one, you can see in the question there, because the purpose of this CNN is to classify between cat and dog. So that's mean the classes there, you have two. It can be dog, it can be a cat, so it's a binary classifier. So another things that you can identify is at the last layers there, where this is the layers number 8 there, which is the output layers. So if the output layers consists of softmax layer, of course our CNN should end up with softmax layer, and the number of neuron is equal to 2, meaning that you have a 2 classes classification or classifiers. So meaning that if you have a 2 classes classifier, you can consider that classifier as a binary classifier. Okay, so the question is, from this architecture, can you write the MATLAB code? Okay, can you write the MATLAB code that can represent these architectures? So if you want to do that, then you must go to this code. Okay, when the question asks about can you write the MATLAB architecture, the MATLAB code that represent the architecture, you don't have to write the whole code to represent that one. Okay, the one that we want is only this part. Okay, the architectures. So let me just copy this one, and then we try to create a new M file, just to make sure that just to make sure that we can compare how to convert these architectures into this code. Okay, of course this one is not that code. Okay, so as you can see that again, why I put a space there is because to represent each and every layer we have in this, okay, in this architecture. For example, here we have 1 2 3 4 5 6 7 layer, while this architecture we have 8 layers. So how to convert this one into this one? How to, given this architecture, can you write a program that represent these architectures? So again, the first layer should be the input layers. So in MATLAB, you should should not you should use this function where it's a input layer function, where the input is image in image format. So that's why they call it image input layers. And then the size, you change it into the one that we want in this, as in this question there. So you put 5 times 5 times 1. And then next we have a convolution. So convolutions there, of course, this example is not a good CNN, because as you can see there, the numbers of filter involved in layer number 1 is only 1. Okay, of course, in reality, CNN should not have only one filter. It should be more than one filter, but this one is to make you understand the fundamentals. So that's why we simplify the architectures. Of course, it's not a good CNNs there. So to convert this one, okay, to design this layer, second layer, then you need to call a convolutional two-dimensional layer. And then this one is the size. Okay, again, this is the size. So size is 3 times 3. So you put 3, and then you have the number of filter is equal to 1. So this one will become 1. Okay, and then strike equal to 1. So by default, of course, this function is consists of strike equal to 1. So you do not have to change anything. So and then how about the padding? So if there's a paddings there, or in other words, let's say I put, when I said paddings, means padding is equal to sames. Okay, it's the same things there. Forget to change this one. Okay, doesn't matter if I put paddings, meaning the padding is equal to same. Okay, so padding equal to same. So that's similar to this one. So you don't have to change anymore. And then after that, to represent this second layer, you don't you don't just need this function or this layer, you also need this one and this one. Okay, meaning that the second layer should have these three three combination operation, meaning that every time you are using convolution, you should apply the batch normalization layer that, like I said, like what we have discussed before in the previous class. And then of course you must end up with this activation function that which is the ReLU layer. So like we have discussed in the previous class, every time you apply the convolution layer itself represent by two function. One is a convolutional operation, which is this one, and another one is activation function. Okay, the one that we add additionally is this one, which is the normalization, which is to avoid imbalance in each and every features, or in each every feature dimension, that because each and every feature dimension have different scaling, so that we want to remove the scaling different scaling factor. We want to have a normalized value, so that's why we put a batch normalization layers there. So that is the purpose of batch normalization layer. So meaning that the layer number 2 here is represented by these three lines there. Okay, so then how about the third layer? So the third layer is convolutional operation. So meaning that you need to have these three. So I just copy. So this is your third layers there. So the size there is same, 2 and 1. So how about the paddings there? Since you don't have since there's no paddings there, then you can put I think none there. Let me check first. Okay, I think that if you try to install the latest MATLAB, MATLAB 2020, they have some effort to remove this parameter in this function. Of course, one of the toolbox which is have a rapid progress in MATLAB is this toolbox, which is a deep learning toolbox. So that's why you can see that for each version they come out, when they release the new version, they always change a little bit on the format, but of course that will make us very difficult for us to to trace the latest function that represent the architecture. But never mind, in our course we just use this format, meaning that if you, for example, you want to set the convolution without padding, then you just can delete this one, meaning that it's something like this. Okay, so by default, if you don't touch the padding parameter, so there's no padding involved in this convolution, so you just can write something like this, okay, to represent the layers number 3. So of course, again, you need to include as well as batch normalization and the ReLU layers there. Again, after that, the layer number 4 involved with a pooling layer. So pooling layer, you just use a single line there, maximum pooling 2D layers. And then what's the spec? We have a 2x2 filter, so this is the size 2x2, and the stride there equal to 1. So if the stride equal to 1, so you just put the stride equal to 1. And then again, if you don't involve, if you don't set the paddings there, then by default no padding involved in these layers. So if there's a paddings there, then you need to include as well as paddings there, means that you must put something like this padding. Okay, and so on. So but because in this architecture we don't have any padding, so that's why we don't set the paddings there, because by default if you don't set the padding, there's no padding in that layers. And then what is happened at the layer number 5? So layer number 5, we have a convolution, so that's why we need these 3 layers back. So I just copy this one, so this one becomes layers number 5. It's a convolutional layer. And then you have filter size is 2x2, so you put 2 there, so number of filter is 10. And then so you have stride there, so that's why you need to include the stride. Or you don't have to include the stride, because like I said before, convolutional layer, if your stride equal to 1, then by default, without setting the stride, it will automatically set the stride equal to 1. So because of no padding, so you also don't have to set the padding, because by default, if you don't set the padding, then there's no padding in this function. So only leave like this. Okay, and then again you need to include the batch normalization as well as ReLU. Okay, finish layer number 5. How about layer number 6? Layer number 6 is a fully connected layer. Okay, I just delete this one because this one is the old one, the layer of the previous code there. Okay, this one is as well. So the layer number 1, layer number 2, layer number 3, layer number 4, layer number 5. So layer number 6 is fully connected layer. So fully connected layers, you just copy this one, that will represent the fully connected layers, or layer number 6 there, fully connected layer, where the new number of neuron is equal to 20. So I set it into 20. And then layer number 7, you have another fully connected layers, where the new number of neuron is 10. And then the last layer, which is our softmax of 2 neuron. Okay, for this one, then like I said before, normally for the output layers, you should have these 3 line. Okay, it's a combination of fully connected layers, softmax before classification layers. But because here layers number 8, because the neuron is equal to 2, number of neuron equal to 2, then the fully connected layer of the last layer must equal to 2. Okay, as you can see, that is the difference there. Okay, you can see that is different there, meaning that this fully connected layer is one layers. This fully connected layers is another layers, but layer number 8, even there's no fully connected layer mentioned in layer number 8, but automatically, because you want to have a softmax layers that consists of 2 classes, then you need to have a fully connected layer where the output is equal to 2. Okay, so the question is that you might ask that in this fully connected layer is like your typical A and N, means that the operation is a matrix multiplication. So if the operation is matrix multiplication like our A and N, so what is the activation function of this layer? Okay, because if we talk about the convolution layer, you have a ReLU layers, which is which will create a ReLU activation function for these convolution layers. But how about this one and this one? Okay, for this one and this one, there's no activation function, or in other words, when we said there's no activation function, it's like you put identity transformation function. What is the meaning by the identity transformation function? I'm sorry, identity activation function or linear activation function, means that the output that produced by this matrix multiplication is directly going towards the output here, meaning the net is equal to O. Okay, because your net is equal to O, because you are putting the identity activation function, meaning the input value is similar to the output value, so your net is equal to your O. So that is what happened here and here, but not here, because this one, what is the activation function of this one? Of course, is a softmax activation function. So make sure that you don't get confused with that. Okay, so now we already create layers MATLAB code that represent this architecture, so that's how we write the code. Okay, but of course we cannot run this code because this is just a architecture, or your CNN layers you already designed, but of course you need to transfer into this kind of this kind of code before you can implement it, meaning that you need to have a data set, and then you of course you already designed this architecture, then you have to set the training option and so on. But of course, because this is just a tutorial, of course this one is not good at all, because again, like I said, it's very it's very rare to have only one filter for each layer, because that is not the purpose of CNN. Because for CNN, the more filter you have, it will create better things there. So so one number of filter is not enough to design a CNN. Okay, how about we talk about another problem? We still using the same problems there, the same question there, the same architectures there. Okay, now given this is the input image. Okay, again our input image is 5 times 5 times 1, so it's a grayscale. So it has something like this, 5 times 5, and then the depth size equal to 1, so we don't have we only have one values there. We don't have more value on that direction. So given the input image is this one, of course I don't put numbers there. I put just x1, x2, x3, x4, x5 up until x25 there. Okay, of course you can just assume that there's numbers there, and then given the filter, which is according to this one, which is y1 up until y9 is there. So this filter is at this layers number 2. Okay, So assume this filter is the one of the, this is the filter that happened at layer number 2. So can you compute the output of the output feature maps after you execute layer number 2, given the input is this one and the filter that involved at second layer is this one. So how do you do that? Okay, of course you just simply using the convolutional operations there, and again you must take note there, because our padding is same, meaning that actually you are extended, because the filter is equal to 3 times 3, you just extended 1 pixel size, 1 pixels borders there. Okay, you add up 1 pixel border where each and every values here equal to zeros. Okay, so the purpose of this one just to make sure that when you do apply the convolutional operation, you will get the output which is the same size as the input matrix. So it should be 5 times 5 over here. So it should be 5 times 5 over here. So how to compute? I just show you one example. I think it should be here lah. It should be here. Okay, how to compute this point? So this point is at this points there. So meanings that let me change the colors there. Okay, so this one is the corresponding point of this point, so meaning that you must put the filters there, okay, at this area. So this one all become 0 0 0 0 0. So to compute, let's say I put this one as a z1, so z1 is equal to 0 times y1 plus 0 times y2 plus 0 times y3. Okay, and then plus, of course, this one 0, this one 0, this one 0, and then this one is also 0 0 y4 plus 0 y7. Okay, because this one, this one, this one, and this one, this one, this one, this one, this one, and this one is 0. So because this one is overlap with this 0 value. So and then plus x1 y5 plus x2 y6 plus x6 y7 plus x7 y9. Okay, x1 y5, x2 y6, and then x6 y8. Sorry, this one is y8. Okay, sorry, this one is y8. Okay, because y7 is already here. So that is how you do the convolution. So once you get the z1, and then you slide the windows, slide the filters, then you get z2, and then you get z3 up until z25. So that is how you compute. If the question asks about how to find the output feature maps after executing the layer number 2, just remember that again, this is just a convolution. Okay, we can consider this one as our net. Okay, it's not our O. So to find the matrix O, because the question asks a output feature maps, that is mean when we talk about output feature maps, it's mean the matrix O is not a matrix net. Net is not a net matrix, it's a O matrix. So again, O is equal to your by default, because we always use ReLU, so you must ReLU with your net. And again, if you talk about ReLU, the activation function is look like this. Okay, So anything negative will become 0, anything positive will become will copy the value of the input value. So meaning that if you find this matrix equal to negative, your z there is equal to negative, then you change it into 0. Okay, you change it into 0. But if you find out yours and the rest, you just remain the value, because of you are using the ReLU activation function. So ReLU activation function is always copy the input value, except if the input value is negative, then you must change it into 0. Okay. Okay, so but let's say the second layer we assume there's no padding. So if there's the second layers do not have any padding, then you don't need to enlarge the size of the input like this. Okay, you just execute normally, meaning that if you have 5 times 5, you execute with 3 times 3, then it will become what here? It will become 3 times here at the output side. Okay, because you don't involve any padding. Now the output will shrink from 5 times 5 to 3 times 3 if there's no padding involved in the same layer or the second layers here. Okay, in this case it's second layer lah. It's a second layers. Okay, that is the difference. And the rest, let's say about yep, you also need to familiar also with the how to calculate the pooling. Okay, the pooling also is simple because you just choosing the maximum value among 2 times 2 matrix, because here you involve 2 times 2 filter. So the strike equal to 1, no padding. So you also need to familiar with that. Okay, just check back how the example how to compute the maximum operation. And what else? Yep, you also need to familiar with the how to calculate the volume. Okay, this one is we talk about the content. Okay, means that if we have input, we execute if this input is execute with this operation inside this second layer, this is the output. This is the output matrix. How about the output volume? Okay, I mean when I said output volume or output size, so in this case it should, okay, what is the output volume of second layer? So it should be 5. It should be 5 times 5 lah, because we already done it here. 5 times 5 times 1. Okay, here is 5 times 5 times 1. Okay, at here it will be, sorry, at output after this operation, I just put it up below the I just put it below sorry, I just put it below the second layer. Okay, because that output is after the second layer, so I just put it there. Let me write here. Okay, so it should be 5 times 5 times 1. So why again 5 times 5? Because you set the paddings there, so that's why the x and y size is maintained 5 times 5, because you are using padding. And then the strike still equal to 1, 3 times 3. Then because my number of filter is equal to 1, so that's why it's time 1. So if my filter is, let's say, 10, so it will become 5 times 5 times 10 there. Okay, so it depends on the filter size. But in this question, the number of filter is equal to 1, so that's why the output volume is 5 times 5 times 1. So how about the volume after applying the third layers? So if you talk about the third layer, then you need to, investigate that things start from the beginning at the input layers, because we want to know the size first, because if you cannot just compute here, you must compute the volume here first, okay, at this position, because that will become the input of this layer. So if the input is wrong, then you will get output size wrong here. So that's why you need to compute at the beginning at the input. So because our input is 5 times 5 times 1, and then after executing the second layers with padding, so meaning that 5 times 5 is maintained. Now we only want to know the depth size, because the number of filter equal to 1, so meaning that's why this one will become 5 times 5 times 1. So how about here? So 5 times 5 times 1 become operation of this input of this third layer. So because of no padding, so now it will become, here is 3 times 3 times 1. So why is 3 times 3? Because without padding, then this 5 times 5 input will be very shrink into 3 times 3, and this time 1 because of the number of filter is equal to 1. Okay, I hope I also by having this tutorial, I also answer the question that have been asked by one of the student, because he or she confused with the depth size there, the depth, how actually depth is generated from the output. So that's how we do. Okay, because in the lectures we have a practical architecture, meaning the depth equal to 3, the number of filter equal to 10. So but because in this tutorial I just make it simplify, so that's why I put it as 1 there. Of course this one is not practical, but it's better it is a good example for you to understand the fundamentals. Okay, so again, then this 3 times 3 will go into this okay, again, how about the filter number 4 there? Filter number 4, you have 3 times 3. Okay, just draw the 3 times 3 matrix there, and then you are applying a maximum pooling with 2 times 2 filters, strike equal to 1, no padding. So in other words, let me take a green there. Okay, in other words, you have a 2 times 2 filter applying into this input 3 times 3 matrix. Okay, so the execution of maximum pooling operation is something like this. Okay, because the strike is equal to 1, so you have only how many there? This is 1 maximum number, this is another maximum number, this is another maximum number, and this is another maximum number. So at the end you only have 2 times 2 matrix at the output size, so it become 2 times 2. So of course this one is a hard, is a not systematic way to calculate the volume. Of course, if you want to calculate the more systematically, you need to you need to check back the formula that we have shown before, the general formula that the number of padding and the size of filter size and so on, what is the F and so on. Okay, so that I have discussed that during when I teach about the AlexNet architecture. So there's a formulas there. This is just if you don't apply the formula, this is one of the way that if you don't without that systematic formula or standard formula, you still can estimate by executing each and every function there. You will know the size or the volume of the feature maps. Okay. Okay, how about volume at this after layer number 5? So again we have 2 times 2 times 1. So here what we have, because the input is 2 times 2 times 1, then you are applying 2 times 2 filter without padding. So what will happen? 2 times 2 filter convolve with 2 times 2, meaning that this is the input, and then you have a convolutional filter at layer number 5 there, same size as your input. If you apply the convolution, then you only get, okay, if you apply the convolution, then you only get 1 point there, 1 point, because this one convolve with this one, you only get 1 point there, 1 pixel values there. But because the filter size is equal to 10, then the depth there equal to 10. Okay, 1 times 1 times 10. So the size of your the volume of your output after executing the layer number 5 should be 1 times 10. Okay, so that's how it's work. Okay, that is the things that, okay, I think that that is the things that you need to know and need to understand, and how you need to have a skill in translating or imaging the matrix, or the operations there, the size and so on, and make sure that you understand how to interpret this format, because this is the this thing is only we only apply for these courses. Of course, there's no standard format for represent the architectures.